So I'm just going to spend some time studying the editor doc manager class and trying to understand how they create. I'm probably gonna change the function there first. I'm gonna move the function to the layout folder, and I'm not really sure if I'm gonna start with the editor because it might be unnecessary. So yeah, I just wanna see. I wanna understand the logic that they use for creating and managing the docs on the editor, and then try to create something similar. But I'm probably not gonna do the same thing that they do there because the stuff that I'm gonna build is probably gonna be different. So I think it might be easier to start from the beginning without anything. And I'm probably gonna go manually through the source code and maybe use the debugger as well at some point. I think here isn't doing it. I'm gonna clean up the way that I was doing things before, as adding childs with this thing here. So I'm gonna delete all these functions. So as far as I didn't test that much because I was studying a bunch of other stuff since last time that I did this. But as far as I can tell, it seems to be working fine now to create the stuff from code. There is a major downside, which is that some of these functions that they use from C++ code, they don't cache on the class. So this can be a, a very annoying problem. But so there's two options. One option is to just change the classes so that they cache. And the way you cache is just by adding the property on the class. And when you do that, then Godot and the editor are gonna automatically save them to the file once you change the state of the class. But it seems for the control nodes, like some of these values here is not caching. And the other thing that is kind of hard is to figure out which ones are cached and which ones are not. So the ones that are not cached, I assume that the way that they usually do it is you are gonna implement on using GDScript probably from the editor. And I think all the other ones should be cached automatically because then it's just translating whatever shows up on the inspector doc is what is registered on the class as a property. So if anything that's if you have to do something that doesn't show up there, it means that it's not cached. So I think that if you're building the scene from C++ code, then I have two options. One of the options is to change the class so that it starts caching, and the other option would be to create another class. So I'm debating because it is kind of hard to think about what is the best approach. And since like some time ago, and I was thinking about that, and I thought that the GD extension would be like the equivalent of creating GD scripts using C++, but GD extension is just more similar to modules. It's basically the same thing. The only difference is that the GD extension allows you to create a dynamic linked library, and the modules are static linked library. So modules is more like you're compiling as part of the engine, and extensions is like you're compiling a library outside of the engine, and then you're linking the library at runtime into the engine, as far as I understand right now. But the functionality is the same. So, and I think this is a like kind of a fundamental problem with the way that they design Godot, probably. But it's like everything else, there's trade-offs, but I think that it is more fundamental because they design everything with an object-oriented programming in mind. So the problem is that as the variance of data increases, it becomes harder to scale this stuff because you are more incentivized to create functions instead of classes. But if I want to reproduce the behavior that you usually get from GD scripts using C++, then what I have to do is create a class that inherits from the other class, and then you put the extra functionality on the notification function. But the problem with this is that for each time that you want to develop a different functionality for something, you have to create a new C++ class. And I am contemplating, but I'm not really sure if it's good or not, like to figure out a way to create either a class or some functionality that allows me to just compose classes based on new functions, because that way I would be able to create the function once and then reuse the functionality to change classes that already exist on the engine. So one of the problems is the tooltip here. This is the thing that I'm thinking about now. Because now, based on the system that I created, it allows me to save the nodes with custom names or whatever name I want, which solves the problem of the labels of these pop-up menus here. But the issue is that even if I set through the editor here, it doesn't set the tooltip. And the reason why it works on here is because I assume that it is a property of the class that works at runtime based on the main menu because of the way that the functionality works there. So let me show this first actually. So I think it's operations. Yeah, so it's basically this function here. So it comes from the pop-up menu, no, from the main menu, and which is the menu bar class. And the main menu is gonna have all the other menus as children. So like each selection here is a child of the main menu. The main menu is the box that contains all of them. And this is basically a very simplified version of the editor layouts that are created from this C++ code to study how the editor layout works. So it does work based on the index. So depending on what pop-up menus you add as a child of the main menu, you can set the different properties based on the index. So the way that they do it from the editor is basically setting up with this function here. And this function is going to get the pop-up menu based on the index. And then it's going to set the metadata for the pop-up menu. The metadata is on the object class. And I still don't understand very well how it works, but it's basically, I think it's a dictionary that allows you to add custom properties on the object class if you want. So I assume that the way that they draw the menu bar is going to have some logic that is going to depend on the metadata of the pop-up menus, and this happens on runtime. So from the editor perspective, this works because the editor is part of the engine on runtime, and the way that they decide whether or not they're going to run the editor is based on command line arguments that you pass when you're running the engine executable. So based on that, they're going to create the editor node, which is the root node of the editor, and then they're going to add to the scene tree. So it's different than creating the scene or the application from C++ and then saving to a file, which I think is the way that all the projects are going to work, because the difference is going to be on the caching. So the way that it usually works is that you create the scene and then you put on the file, and then the engine is going to take the state of the scene and the application from the scene files. And then based on the way that it parses, it's going to recreate the state, which is a tree data structure, from whatever you have on the scene file. But then this is the problem because it doesn't allow you to, like, there's this difference between the way that they are gonna set here because it works since it's on runtime. They're changing the state of the class. But if I wanna do it the way that I'm doing, I have to cache this stuff. So I can't rely on the runtime functionality. So either I create another class, and then on the other class, and this is kind of the problem because the other class I would have to put like this information on the constructor, for example. So I would create a class like this, and then I would add on the constructor the other ones as children, and then I would set the properties so that if you encapsulate the functionality inside of the constructor, when the editor reconstructs the node, or when the engine reconstructs the node from the file, it's going to run the constructor for the class, which means it's going to update the state at runtime of the class, and then it will probably work. But then it's very annoying because every functionality and every state you want to change, you need to create a new class. And this is a problem because then it forces like you to have a rigid scope. So I think that this is the spectrum that people talk about game engine architecture, is that usually for games that have high variance in data, you're more incentivized to create an entity component system approach because the more data you have, the more flexibility you want on the functionality, just the flow of the data. So you're more incentivized to use functions instead of classes. So the way to solve this on the editor, I think, if you want to add the same functionality here, I think what you would normally do is you would go from the class here and then you would attach a GDScript, and then inside of the GDScript you would put a functionality on the notification, because the GDScript is going to highlight what happens on the notification function from C++. So on the ready function from the underscore, I think it's underscore ready on the GDScript is the equivalent of the notification ready on the notification function of the C++. So you would create the GDScript, add functionality, and then it would work. And then I thought about it like, but it seems like it is even easier to do it on C++ because instead of creating a file for each thing, you create a class. So it's kind of like the same thing, but it is kind of annoying because it would be much better, I think, if you can create a function and then you just reuse the function. Or you cache everything. I think those are the two. But I assume that there's probably a downside to cache all the information, so this is kind of the issue. And it's also going to be a lot of work, I think, if I want to cache everything, so I'm not really sure what to do. I think probably to start, I'm going to just I think it's probably better to just create new classes and then customize this way because the other approach is going to be very hard to think about. So I think what I'm going to do is just change the scope, and then I'm thinking about dividing the the doc into subcomponents where each major component becomes its own class, and then I have I'm gonna have a standard like beginning of a layout or a dynamic way to create the layout. As soon as this. So let me move the functionality there. I'm gonna remove this things, then I'm gonna move to the layout folder. Then I'm gonna think about this more. I'm trying to think because the issue with doing the class is that this is kind of the fundamental issue because it's gonna depend on the data. So the question is how do you develop so that you can. So obviously the first thing that comes to mind is to just uh, like create the class and then expose the information of the class to be changed with functions. But then it becomes a whole problem where you're gonna have to cache the states of the class. But I guess that this is probably the best way to go about it. So I create a new class, encapsulate the main components, then create functionality that changes the class based on data. I think that's probably the way, because then you maintain flexibility, and then you cache based on the properties of the class. I think, for example, on the thing there, instead of creating manually one by one, I would create a function that saves everything to a vector or an array. Then I would expose the function, I would expose the variables. But then how would I create this? That's the problem. Because the problem is that I have to cache. But maybe the function, yeah, the function would keep track of the information inside of itself. And then I would have to serialize everything based on the parent class. Would replace everything, but actually it would be kind of hard because it's not the same pattern, but doesn't matter. Or the other way would be signals, but then I would have to create another function for each class. But maybe this is the best way, actually. It could be like an easy solution. And maybe this is the best way. So instead of changing the whole class, I just add, whenever there's a functionality that changes things on runtime, I just create a signal for the class in relationship to itself. And then I can create an event. Maybe that's the best way. Because then it essentially allows me to customize the properties of the class that you don't have access to on the function by just putting like connecting based on the signal. So I would use signal serializer and then I would connect the class with its own function, and then I create the function, then I change the properties of the function. Then when the signal serializer is when the class is initialized, it would emit the but then might be a problem because I think it would be a problem because I can't guarantee that the signal serializer is gonna be. But I think it will run after. Yeah, but this is the problem. If the signal serializer runs after all the classes are initialized, all the nodes are initialized, then I can't emit the signal on the constructor of the class. So, but maybe I can put it on the notification function. So maybe I can do like a synchronization thing where the signal serializer emits an event and the classes subscribe to signal serializer. Yeah, but then that would be. Maybe I can encode the logic on the signal serializer and then I don't need to emit events. Because I'm gonna have access to the nodes. I can just use the get node from the sync tree to get the nodes, and then I can call the function manually. So I guess I can use the class B as well to see if the function has a method. So maybe this is the best way actually. So I can create a function that, like a standard name, in the same way that you have the notification function. I could create a function that could be like customized runtime state or something. And then I create a simple data structure on the signal serializer to determine which nodes are gonna run. So I could create a vector maybe, and then as long as I use the same, so like the name of the variable would map to the name of the function that is supposed to be run for that node. So I would each node that wants to run that function, I would do the same way that I'm doing for serializing signals. I would just specify on the signal serializer the name of the node, and then the signal serializer would put the node, the name or string name of the node on the vector, and then after it connects all the signals, it would loop over all the classes that exist on the vector, the names that exist on the vector, and you would find the node. You would use the sync tree to find the node for that name, and then you would check to see if that node has the function using class DB. And if it does have the function, then it runs the function. And then on that function, it allows me to do anything I want. But the thing is, I would have to create a standard. Uh, I would have to create a standard arguments, or maybe I'd just do a void. Yeah, the easiest thing would be to do a void, but I'm not really sure if this. But maybe it would be enough because for most of the things that you can set from the code, that depends on the runtime because they don't change the values of the class. It doesn't require arguments for somewhere else, I think. Unless you have a situation where you're connecting two different classes, but then I think it would be just normal, like it would usually be done with normal signals, I think. This is an interesting idea. And then I can potentially create several different standard functions. So like instead of having the GD script, I can create like all the functions that the notification has, and then just run. So like the signal serializer would be like uh, generic script. So it would be the same logic, but this sounds very interesting. So maybe I could break. I wonder. So the only thing is I would have to change the name, I think. So what I need to do is find standard names or think about. So I think this is a very good idea actually, because it allows me to do the same functionality that you can get from GDScript by using C++, but not having to create a new class every time. Because I can change the existing classes every time that I see a functionality from C++. I can just create an additional function on the class, and then it decreases the chances that would fuck up other places because I'm just adding something new. So the remaining code is going to be the same. The only thing that would change is that I'm adding extra functionality. The only problem with this is if the functionality if there's situations where the functionality depends on other classes. So, but I think that if I create the standard in the same way that GDScript works, then it should be the same thing because obviously they design everything having GDScript in mind. So anything that you would do, you would want to do from C++, it's probably possible to do with GDScript on their class. So for example, you could like if you need a node from the function there, then you would use the sing root, for example, on the class to find the node as well. So like the thing that we're contemplating is whether or not to make the standard functions receive some argument or not. And I could use a templated function, but then I think it's just like overly complicated because I would have to keep track of the arguments on the signal serializer class. So it would be like a similar logic, but maybe that's the best way to do it because then it allows me so it's gonna be the trade-off. So if you do it templated in the similar way that they did the emit signals, then it allows maximum flexibility, but it's kind of annoying to set it up. Emit is better. So I could have a function like this. This is what I'm thinking. And then inside of the function, do the same logic that they do here. So what happens here is that on C++, you can put, when you put these three dots, is the same, it works in the same way as JavaScript works. It's just a spread operator. So it's whenever you want to pass an arbitrary amount of things, I guess. And here is specifying the types. So this means that you can pass an arbitrary amount of arguments here of different types. So based on these arbitrary amounts here, you would be like copying an array instead of another array, for example, in JavaScript, where when you put the spread operator, it's just gonna take all the elements from the previous array and it's gonna put on the other one. So here is just getting all the arguments, and then based on the overloaded constructor on the variant, is gonna translate each type of each argument into a variant. And then they pass this as a pointer to a pointer here. So what I'm thinking about yeah, but I guess it wouldn't solve anything because I'm just adding an additional function. It would be the same as changing the notification function for the class. So it doesn't make sense. Because it has to be something that allows me to change the class from outside of the class, I think. But maybe I can use the same logic and then just create another function. But I wonder if it would be the same thing. I guess the annoying thing about this is that in order to make it happen, you would probably need to think about a way to do the same thing that they did for the other parts, where On the signal serializer, I cache the callback function instead, and then inside of the callback function, I get the instance of the class, and then I change the instance from outside. Because what I'm trying to avoid is to create a new class every time I want to change the functionality, and instead use a function, because it's just about the gradient of variance. So the more variance you have, the more incentivized you are to create functions instead of classes. But the problem is that if I do it in the way that I was thinking about, then it would be just the same thing, I think. So like the other way would be to get the address of the function. So like the problem is, yeah, maybe I should try to do that. So I can create like see how to create a function pointer type, and then I create a file that has functions that are gonna change the behavior of classes. Then inside of the signal serializer, I create a function that receives a function pointer, and then it caches the function pointer based on the name. But I think the problem is like how would you save this? That's the issue. I think it's not worth it thinking about this. It's probably better to just create classes in the beginning, and then if it is very annoying, then I'll think about how to change. It might be very annoying, so I'm trying to think about. Maybe I should think about this later and just study the other thing. What's on the wrong file? Maybe I should just put this path here. It's better. Let me. The thing is that I'm not really sure if it makes sense to create more files or if it's gonna be more of a class that's based on the state of the class, it's gonna create several different layouts, or if I should create another file and then create different types of layouts based on the file, based on different functions. I think probably you should start trying to change the editor here. I guess I have to study the editor doc manager to see how to create from the beginning. So there's both this thing that I'm thinking about and the other thing that is kind of annoying, which is the states of the classes that are not gonna be I'm not gonna be able to set from the code because it depends, like they change runtime variables. There could be like a class that I use that is just to manage that is not cached on the sync file. Just C++ class that I create here to manage the creation of the layout. The thing that I also learn about the way that it works is the whether how does Godot cache the thing. So like now that I'm using this add child external, it allows me to select when I want a node to be part of the main scene and when I don't. So I can create a class that encapsulates everything, and then I can choose which nodes are going to be exposed on the editor by selecting when I use this or when I don't. So maybe I could create everything from one class. Maybe that's the best option. Because then like I can create the layout as a base class, and then because then I don't have to worry about this stuff because I know that it's always gonna as soon as Godot is initialize the roots of the nodes, it's gonna initialize the states. So maybe that's the easiest way. Because the main reason why I did all of this stuff is because of the not being able to expose the nodes on the editor. So I guess I can try as an experiment. So what I can do, I'm contemplating whether or not to maybe create another function. I think I'm gonna create another function. So I'm gonna create another function, and then I'm just gonna put copy paste the. But if I do that, that's kind of bad because I do have to save. Like I'm not gonna be able to. The root node has to be something that I can save this state. I think. So let me think about this. Maybe I should just go over the source code for the thing as I think about this. It's kind of confusing to think about because I'm not really sure what is the best way to structure things. I guess in the beginning, it would be better to think about it as different spots. So probably one thing that all applications are gonna have are gonna be is gonna be the tab there in the on the top. So it's gonna be the tab and the divisions of different spaces for different things. So this is what I'm trying to think about. So I think like it makes a lot more sense to make a class, but then it defeats the point of having the thing there. Maybe not. Maybe just create another file and then I just put on the like I can create have several different options obviously, but I can create one class like this one that it just separates the docs based on the state of the class. So I think probably it's kind of hard to know what to do here. I'm thinking about creating a class and then I just from the root there I just add I created one node and then I add the node as the root and then inside of the node I use that child external to add the other ones and then so basically adding here. So I would change this function here to have something else or to call something else that creates a class that would create everything. So mainly I'm thinking about this now to be able to see probably what I think would happen is it would allow me to connect signals and do everything else because the root would be a part of the thing. So like this would append to the existing root. So it would be a subroot, but then the other one would be just to have the initial thing. And then because this one would be part of the thing, would initialize everything. So I'm not really sure if it's a waste of time to try to understand this one. I think it mainly is gonna come down to, and it is very annoying to think about this stuff, but it's gonna come down to the split container and the HBox and VBox, I think, the layouts. So this is the stuff that I'm trying to think about. Like it would be, so which one was the best approach? So one approach is to create functions that combine the different elements, and the other one is to create a class that based on the data of the class, it changes the structure. So what would be like, what is the challenge on both? I think it comes down to the data. So like, it's how the classes are going to change. I think creating one class that has everything is better because it makes a lot easier to set everything up because then you can do everything inside of the constructor of that class. So I can't put the node because the node isn't registered. The editor node isn't registered on the class B, I think. So I can't just use the editor node, for example, to see what would happen if I push the editor node. But maybe I can try to do that actually. I guess this is probably the best thing to try at the beginning. And then the only thing I would do is change the, but I think it's gonna crash. I'm pretty sure it's gonna crash because there's classes that don't, they're not registered on class B from the editor. But I guess I can try to do that. But I'm contemplating now because it's kind of hard to think about clear direction. It's kind of, and this is how it always is in the beginning, and then it becomes clear later. But there's this like two approaches that I can do. One is to do everything based on the composition, so create different nodes and then add them together. And the other one is to create everything. So like you push one node and then all the other nodes are gonna be done on inside the constructor, the main one, which would be the root. But the challenge is which is very annoying to think about as well, is the structure of the layouts and how the structure of the layout is gonna change depending on the different situations. It's gonna change. Like the problem with creating a class is that it becomes harder, I think, to do it for a generic way because the structure of the class is gonna have to reflect the variance of the differencing layouts and applications. So like the layout is the entry point for the entire data, or maybe not actually, but for the scene. So for each scene, the entry points, the layouts, and then for each application is gonna change a lot, I think. Whatever is gonna happen. So like the flow of data is gonna be determined by the layout. And if I have to encapsulate everything in a class, then I think it becomes very hard to design everything. Because then how do you? But I think like I can't decouple these two things from each other, I think. Unless I do the stuff that I was saying, where the C++ class it's used only to create the tree structure that is saved on the thing. But then there's the problem of the state of the classes as well. The thing is kind of, I already looked into this a couple of times, and it's kind of hard to know or to understand what they did here because it's very confusing. But I assume like this is the class that is gonna separate everything. So like they create this structure before by pushing a bunch of HBox and VBox, and then they use this editor doc manager, I assume, to put each main doc into its own parts there. This is what I'm thinking is probably better to try to do it from the beginning because I don't like the way that they did this here. But the main challenge is this separation between class and functions. This is what I'm trying to clarify now. Because the problem is that you have the structure of the layout that is determined based on these classes. And then, so you have the structure, which is like the template, and then you have the data, which is the components that are going to be inside of the template. And the components have a lot of variance because they depends on the, so I can imagine like a way to create a class where based on like the properties of the class or the functions, you design the structure of the layout. So what kind of separations it's gonna have, and but the problem with this is that then like how do you make sure that the functionality of the components that are parts of the layout are not trapped inside of the main thing, if that makes sense. So I guess I have to clarify the how the split works and the values. I think I need to clarify the classes more before I think about this. this doc split container. So maybe this is what is missing there on the other one. That I'm not setting these values for the tabs there. There should mainly one thing that is weird with the one that I have there, but I'm pretty sure it is correct because I compared with the other one that I did manually, adding the classes on the editor, and is that split container, the separation between the containers in the one that I created from code, they only happen on the horizontal level. And I think the way that it's supposed to work is that you're gonna have two separations vertically, which are the inspector doc and the file, which creates the dockable left and right parts, and then obviously the middle, but it's mainly just shoe. And I think there's two extra ones that are supposed to be horizontal. We separate the file system with the one that shows up the scene nodes. And on the inspector doc, I'm not really sure what's the purpose of the horizontal one. But when I create from code, there are four vertical ones instead of two vertical and two horizontal. So I assume that this has to do with the some logic of some of the classes, or because I'm not adding some of the nodes, and when you add the nodes, then it changes the layout, even though the splits are on the same position. So this is the thing that is kind of annoying, because if it depends on which class you add, then it becomes very tricky to set up like a generic way to create the layout. That's kind of the problem. And there's also this part of the items there, the sub items of the main menu are not showing up, even though I set their names now. So I assume that it has to do with the values that they set here as well. And maybe it's better to start from the beginning. Like start from scratch and then see. So let me, I think I should probably write down the options that I have here, or that I'm thinking about, and then contemplate which path should take. Because it's very confusing in the beginning. Like the most challenging part is like thinking about the different situations. So like I have to think about the generic way and like think about several different options of structures. So like I'm trying to create something that in the beginning, based on whatever I put there, is going to create the structure of the page, and then it's going to allow me to compose the page based on different components, so that I don't have to think about all the time. Uh, so for example, let's say I want to have a page that has something in the bottom and something on the top. I would create the same class and then just pass different data. And you would create the standard layouts, and the only thing would change is the data, is the components that are parts of the layout. But I'm not really sure what's the best way to go about it because of this state. So I think that the challenge might be that if I create the class to encapsulate everything, then it becomes too, it limits too much, or it becomes too hard to differentiate based on the components. So I guess the question is whether or not if I, because this class would have to be the roots of the scene all the time as well, I think. And then the roots would, and maybe if I do things this way, I also don't need the signal serializer. So it would simplify a lot, because I can just do everything on runtime from the roots. But then the problem is that, like, yeah, I can't create on this the constructor, because if I create on the constructor, then it becomes. But unless I create a different class for each time, for each thing, but then it defeats the purpose. That's a problem. I guess that's the tricky part. So like the functionality inside of the constructor has to be detached from the data, which are the classes that make up this thing. Otherwise, I think it defeats the point. Because like one option would be like if I create the class like the editor node each time I want to create a scene, then each scene is going to be too unique, and then you're wasting code because there's things inside of the scenes that are going to repeat themselves. So it makes a lot more sense to extract the things that are always the same and put that on a class, and then from that class you do everything else. That makes a lot more sense. But the challenge is like how to do that, because if you extract the thing, then you have this problem with this state. So the challenge is how do you design the class without forcing stuff on the constructor, but then it defeats the point because of this state. Unless I design based on the same way that I did the signal serializer, where I think about, so based on the layouts, I separate the nodes. I think that is very similar to Barn set actually. It's starting to become more clear on my mind actually, what is going on. But this is very hard to do. I can do it based on heuristics. So like what is happening here is that you have a tree data structure that is going to subdivide space. So like I'm trying to create a class that is going to create a tree data structure where the nodes are going to be subdivided by space, which is going to be the layouts. And then each node is going to depend like what the type of the node is going to depend on the data of or whatever you want the scene to be. Like just the structure of the page would be like a Barnes-Sutz implementation or like something similar to Barnes-Sutz where you're dividing the space. You're dividing the space based on a tree data structure that creates the structure of the layouts. And then the heuristics you use to create the subdivision that creates the tree would be the different layouts structures you have, which would be a gradient. So if you want strict subdivisions, you would use an enum. And if you want a continuous subdivision, you would use a string because the string is a finite state machine, I think. So like it allows you to have, it's basically a gradient of float numbers, I think. Because the more variance you have, the more numbers you need to represent the variance, and obviously it goes to infinity, but for strings it would be obviously not that high, but I think enums probably makes more sense to do this. I think I'm gonna draw on Draw there, I think, what I'm thinking about. Because then, like, if I can do that, then I think it allows me to kill two birds with one stone because I can do in the same class, I can connect the states. So like, it would be a class that manages that creates the scene based on the data, and then I essentially can create any scene, like all the possible scenes for all the possible pages based on one node. And the difference between them, it would be just the data that makes up the structure of the division, and the node would encapsulate the logic for each subpart of the tree, which could or could not be part of the scene as well. But when it comes to the logic of the class that creates the root, it wouldn't be. Like the logic would create the main nodes, let's say, and then inside of the main nodes, I could add other nodes as external to expose them on the scene as well, or not, depending on the functionality of the thing, which allows me to have the composition from the root because it's a multifractal pattern. So like the node follows the same pattern as the tree because the only thing that changes between them is the scope. So the challenge is how do you create heuristics for creating the tree data structure that subdivides the space based on heuristics. So we have an enum to start. The enum determines the structure of the tree, which creates the blocks of the docs of the page. And then based on the enum, you have the information of like the subdivision of the space, and then like you have the initial structure, and then you populate the tree based on the initial structure with the types of nodes you want to populate on that structure. And it would also allow to make it very easy to, because essentially moving docs would be just restructuring the states of the enum. So like for each division on space, you have an enum that represents the division. So like if you change the one doc to the other, you would just change the number of the enum for one to the other. Maybe that's the same thing that they did here. So here, I'm pretty sure that this is the part where, like, problem is I'm not really sure how they are using this class to create the final thing because I think I'm not really sure if it's like here, but I think here is where they initialize the docs based on the classes, and then they use this enum to determine where the class will be. But it's very confusing. Maybe this way is better, the way that they did it. I think it's essentially the same thing, but it's a different way to approach, I think. Because I think what they did with this class is that they create this class, and then based on this data structure, which I'm not really sure, so it's a hash map, they like they're using one class to manage everything. And I'm thinking about, and they do everything on the class based on the data structure of the class. And the way that I'm thinking about is using the class to create the tree, and then from the structure of the tree, you populate the tree based on the nodes. So like you create placeholders, let's say, of the nodes. So you create the initial tree structure with like empty nodes, and then you populate them based on the classes you have. Actually, not empty. You wouldn't be empty nodes. You would be the classes that Godot uses to separate the space, which is the VBox, the HBox container, and the split container. So like I would use the container classes to create a tree data structure from the root class that would create the subdivision of the 2D space based on an algorithm that creates that subdivides the space based on the tree data structure. Then based on the subdivision, I would select the nodes based on the enum. I'm not really sure if it's similar to what they did here. It's here. So they're using these slots, and they're storing this slot on the doc info. And then they store on all docs. So they're mapping the control node, which is the doc here. So the control node is the class. It would be the node that I have there. So they are mapping the node to the doc info class, which is the class that contains the information for the doc. And then they are storing this on here. And I pass the control node here and change the doc state to true. And then they're calling show on the class. I'm not really sure if this like is easier or not. Maybe the update layout is interesting to see. I think the problem with this one is that it's different because this one's not generic. It's just gonna be for the thing that they have there. It is similar in a way because I think what they're doing is that Based on this hash map, they create like the values of the doc based on the enum, and then they do the logic based on the hash map. But I'm thinking about a different way where the structure of the tree, but maybe, but I think it would be fine because the split container should have the functionality to adjust the sizes based on the separation. So I think more about creating the classes, the class that manages the structure and the connection of the signals as the root, and then based on the state of the class, you would allow me to create a docs. So like essentially the only thing I would cache on the main class that creates everything would be the properties of the class that I would create that reflect the structure of the space subdivision that creates the layouts. And then uh, the tree data structure that is created from that subdivision would be like how the classes uses those enums to enums and other variable and other properties of the class to determine whether or not it creates it adds nodes as children of the main thing. So like the initial subspaces would be like the main nodes that are part of the tree that are created based on the properties of the class. And inside of each doc, each node would be like its own subroot, let's say. And then from the node, you can encapsulate whatever logic you want. And I think here is they're creating everything based on the same level. My only concern is that I don't know very well the classes, like how the classes work. So it might be a better idea to study more that because the nuance is like how the state of the classes, how do you change the state of each class based on the layout? So I'm just gonna write this down. I'll be right back. So the part that is hard about this is that I'm not really sure about the values there of the how do they. So I'm thinking about uh creating like having the general picture there and then creating a bunch of questions and then clarifying the questions one by one and then creating the structure of the class. So like I'm starting to think that more and more that this approach is probably the best way to go about it, but it's gonna be very hard. So the key is to create another class. Sure. So I create a generic class that is going to create the tree based on the thing is that like there it would be the couple. The nodes that populate the layout would have to be the couple, I think, from the class. This is the biggest challenge. So maybe I'll have to use both signal serializer and that class. I think it still doesn't solve the problem of updating the states of the nodes from that depends on runtime. So I think that's but I don't see a way to do this from a class. Because anything that you have to hard code on the constructor is gonna depend on the thing, on the which thing it is, which is not very good. Yeah, but I guess then I could change the classes. Yeah, so I could create for each subcomponent, and then I encapsulate the state changes on its subcomponents. So I'm gonna draw on ScaleDraw what I'm thinking there. I I have to clarify the tab size and stuff like that. It's very hard to think about. So essentially, let's say that this is the page. This is the scene. So like the layout is gonna be a division of the scene space. Because obviously for each scene you want to have different things on the scene. So the simplest case would be you only have one component that takes the entire scene. And then that entire component manages everything that is gonna happen. But the problem with this is that is unlikely that you're gonna have uh like you're gonna have different situations, which is gonna require the main component to be different because of the data. So it's very unlikely that you're gonna be able to only create one class that has functionality for everything. Uh, Actually, it's probably impossible that is the case. It is impossible that this is the case. So it's always going to be the case that you're going to have to break down functionality into different components, different classes that will serve different purposes. And this will mean that usually the GUI of the application is going to be a subdivision of the main space into different spaces, where each space is going to have its own logic, which is what happens on the editor and I think on all applications, because all applications are the same thing essentially. The boundaries are always relative. So in this example, I would have like a layout like this, and I'm thinking about. So the challenge is that I'm thinking on how to. There's two different approaches. One is I create functions that take these three different components here, like these two components and the main scene, the main page, and then I create a division base from outside of the classes, and I put the components together in the main tree in such a way that they are going to create this layout here. And then I create variations of the sizes based on the functionality outside. But the way that I'm thinking about now is that I'm going to have one class, and the class is going to be a class that creates a tree data structure in the same way that barn set works, where you have the structure of the tree is a reflection of the division of the space. So the root of the space would represent the entire blue scene, which is the whole space. And then depending on enum or some logic like that, you would add childs or children based on the subdivision of the space. So like in the first way, because you're always going to divide the space by 2, because you're working with a 2-dimensional space. So you would be a binary tree, I think. And then like every time that you subdivide the space, you have 2 different sides. So you would have this side of this one, and you would have the other side, which was the original space, which now is like it would be the remaining space. And then I keep doing this depending on either inside of the constructor of the class or a function outside of the constructor that caches the state of the class based on its properties. So it would essentially work based on the properties of the class. So it could be like an integer, for example, the number of subdivisions and the type of subdivisions that follow based on the enum, for example, or a binary choice. So like F could be binary choice like vertical or horizontal, and then the amount. And the nature of the subdivisions would be dependent on the classes that Godot has, which is the split container, the hbox, and vbox. But I think that the problem with this one is that the original space doesn't count as a, because essentially I would use the tree data structure that contains the subdivision of the space to traverse the tree and then update the tree based on the components that I want to add. So like the initial step is you create the tree data structure based on the properties of the class that subdivide the 2D GUI into the layout structure you want. Then the second step is you traverse the tree, and then like let's say you have a flag for each node, and then you signal whether or not the dock is taken or not. If it isn't, then you can populate that dock based on the traversal and the integer of the subdivision. So like I would have different types of layouts that reflect the subdivisions of the 2D space, and that would reflect on the variable that keeps track of of each dock. And then I have functions that allow me to populate the tree, to update the state of the tree based on the nodes that I want to put on each dock. And then if I want to have the runtime functionality, I would create a class. The classes that I would create would be classes that encapsulate the dock space, let's say. So here could be like the file system, for example, and then here could be bottom panel, and the other one could be 3D visualization. So I think one of the problems is how do you make sense of the subdivision in the first place? I think the problem is like how do you split the space? Like how does splitting the space changes the state of the node? Because the nodes would have to be dependent on the Godot classes and the logic. But I do think that this is probably the best approach. So the other, yeah, but caching I think I can do based on the properties of the class. So I can use class DB for the types. So let's say I store a string name with the types of the nodes for each doc. And then I instantiated the nodes based on the root. But I think that wouldn't be very good. So I guess this is a problem. It's like how do you But I guess you would have the nodes. So the class, the state of the parent class, the root class, which is the root of this tree, would have the nodes that are interpoints that hold the subspace divisions. So like this node here would be like a node that reflects the subdivision of the space. So I think that the challenge is to clarify how like this relationship between the spaces and the classes on Godot and how to encapsulate that into nodes. Because the structure of the scene tree doesn't have to reflect the structure that I use on the class to subdivide the space. That makes sense. So for example, I could have like I guess that there is one question would be if all nodes have to be the same, or if the state of each node is going to depend on the structure of the subspace. Because it's obviously different if you divide horizontally than if you divide vertically because it depends on different classes. And it's also different if you want to add split containers. So I think, yeah, I would have to, probably the best way to do it is to always have the same state and then like make each sub node, which would represent the subspace, to change the state or to change the classes that are actually going to be used on the scene based on the subdivision of the space. I think this is the challenge because you're going to have classes that are actual parts of the game, which would be the VBox and the HBox and the split container. And then you would have the node, which is just the abstract thing that is saved or that it's dynamically generated based on the root node, I think. I guess one experiment I could do is to change this, just see what happens. Let's put here. Yeah, because let's see if I do that. Size control. Let me put this again. Hmm. And this is the thing that is kind of confusing. So now it went there. So I guess I have to see what are the limitations of the classes from Godot. Like how does it work with the how do they take up space depending on the structure of the tree? That's the challenge. It's very confusing as well. So maybe I should study these classes here. The H box, the V box. And the other types of containers. I would have to expose the classes, I think, that make up the layout. But obviously the structure would be created based on the roots one. And then if I wanted, so essentially like I would be coupling, not coupling, but making the division of the space dependent on variables from the root node. So it would allow me to change the layout structure based on the variables that I put there, either based on enums or stuff like that. And I think that the scope of the subnodes of the tree would probably have to be the same, and then on which subnode I would have to. The question is like how does it work with the. Yeah, so I guess what I have to do is create. So first I have to create a subnode, which would be a class that contains member variables, which are going to be hbox, split container, like a class that contains all types of containers as its member variables, and then it decides which ones are pushed through the tree based on the parent class. I think that the remainder like the is more about so like the complexity of the class would depend on how much I want to because obviously it gets to a point where like this it becomes like impossible to do it. Like it would be just for the main level of the thing. Then once you have the main docs, on each doc you have a class that is gonna contain inside of the class the logic. The confusing part is like what is exposed on the editor. But I think that any node that I want to be able to change from the editor, then obviously I have to expose. But then, like, how do you draw the line? I could use a name pattern, but then I think it becomes very annoying. But maybe it doesn't matter that much to have all the same thing. It's essentially like if you create everything from the code, then I wouldn't be able to differentiate from the editor what is the limit of the main roots tree that creates the original layout structure and when the other classes begin because the separation would be done only through the C++ code and what is cached on the scene file is different because what's separating the logic is the constructor of each class. I guess the other question would be if it has a if there will be a problem if I add a child inside of the constructor using add child external. Because then it's gonna it probably will add two more times. So this is a problem as well. But I guess if I don't want to use only one class, I could just use the main class as a way to get the entry points. And then just do the same thing that I'm doing there now. Where I compose the subspace if I want outside and I just use the main one to navigate the layout. I'm not sure if that's too complicated. And that's the reason why it's not showing up there at the beginning. So the size is probably set with the other classes. That should be here. Yeah. If I click anywhere, it's not gonna allow me to move. Mm. I don't know why I didn't add these ones on my code. That tab container. I think it's because I thought is they have stuff from the, or maybe it's just because of the names. I think that the way that I'm thinking about it would simplify. Like it would both simplify in the beginning and it would be more generic. And then like the only difference would be that the structure would be the initial structure would be encapsulated on the class. And then if I wanted to add or compose the subspace based on different classes, I would be able to do it based on an entry point from the original class. So like the main class would just create the first structure, which is the main layout of the page. There would be the tree that subdivide the space based on the Godot classes. And then based on that, you would change the state of the class. Change the state of the, based on that, I would traverse the scene. So I guess the question is how would I cache? I think that's the problem. But I guess if you went as a child, yeah, so the main one would have the no all the nodes because you would have the logic inside of the structure. So I think I would have to encode the logic of the traversal of the tree inside of the root of the class, and then based on the variable, based on the state of that class, it would allow me to know from the outside, because essentially the traversal wouldn't be exposed to the entry points. It would be a similar logic that I'm already using for the other parts, just save. I think that does make sense to do this because even if I have a subspace that I have to compose because I want to expose children, because now I'm thinking that I probably can't, I can't, if I want to have access to the nodes, I can't add them inside of the constructor of another class. It has to be done outside because if I would use this thing here, it's gonna add the same node twice. If I use this inside of the constructor, because when I'm building the scene there, then it's gonna mark both nodes as true, and then the editor is gonna instantiate the constructor, which already has that node, and then it's gonna add the node again from outside. So like you would double the node, I think. because of the construction, because this is mainly to differentiate the final sync tree that I put there. So if I want to have access to the nodes, I should probably compose them from outside and use this function, which would force me to build the subspaces based on the same pattern that I'm using right now, which is just changing the state from outside. But maybe I can encapsulate the changes in state on the class. But I'm not really sure because I think that would be too complicated. For the state, I probably need to think about something else. Sure, maybe should. I guess the compromise would be if I want the state, then I can't expose the class because I have to make it as part of another class. So just change the level. So like you create another class that encapsulates all the other ones, then you subscribe that class to class DB, and then you expose whatever you want from that class, the new class you create. So here, for example, like let's say, I think this specific function, if you set from C++ code, it does cache on the scene file because it changes the state of the class. I'm not 100% sure, but let's say it didn't. What you can do then is obviously create another class that inherits from some other class, and then inside of the other class, you would add this one as a child, and then you would change the state. But then the downside is you wouldn't be able to access this from the editor because I wouldn't be able to add uh, I wouldn't be able to save on the sync file. That's the issue. But I think it's probably better to just focus on one problem at a time. So it's gonna be too hard if I try to do both on the same thing, I think. Obviously, it would be better if I can create just the root class there, and then inside of the root class somehow I put the functionality because the root class can encapsulate both classes. So I would there's probably a way to set the state on runtime based on the logic of the root class. And if there isn't, then I have to think about something else to do here. But like probably the compromise is to create a specific class for each time that I want to change the state. And then on the class, like the class would be just a wrapper for the other class, and then on its constructor you would set the state of the other class, and then just add as a child. So it would be just a placeholder to set the state. I think that's the compromise. I think what I have to do now is think about the structure of the tree there. And here I'm pretty sure that they so I think what they're doing is very similar to what I'm thinking about doing, but they are saving the states. They're doing based on the data structure, the property of the class, instead of creating the tree based on this class. So one question would be, what would change? I think if I do it this way, then it makes sense that I'm probably gonna still live like this if I want to do something else. But I think it would be just like one file, like it would be only one class. And then what would change from scene to scene would be just the state of the class. So it's always the same class because the main class is the one that is gonna subdivide the space based on the properties that it has. So there is no need to create a bunch of functions or separate layouts because the rest of the code would have to be for each project. So I always initialize the class as the root of the scene. Then based on that class I would have a function that sets the initial state of the class, which creates a subdivision of the space. Then based on that, but then how? I guess after I call the function, I would have to change the state of the class right away, because then the other main nodes would be that go on each dock would be uh, you would be added to the main class based on functions as well, I think. So like you have a function that traverses the tree and then adds the node based on the tree. So the main class would create just a tree that has like this structure of uh, containers. So you would be just a class that creates containers based on the initial space. And then after that, I would traverse the tree and then add whatever I want based on the main containers. So one question would be, so like there's the I think the easiest approach is if I'm able to make all the subnodes equal. So that would mean that like the nodes, it would be a binary tree, and the nodes would encapsulate what the state of the subdivision is. So like each subnode of the main tree would be the same, and then inside of the state of the node, you would have the three different class or whatever, how many containers you have there. And then based on the way that based on it can't be on side of the constructor because the constructor has you need to have an empty constructor, I think, to be able to register on class DB because of the object class. So you would have to be a function separated, and then you encapsulate on the parent class. So like this one will have like, for example, margin container, margin, and vbox container, vertical box. And I would use the same class for all the subnodes. And then based on the state, so from this one, I would initialize this node here. So this would be sub3 node. So this one, and this would have an empty constructor and a function called setup, for example. So here I would initialize. So in this class, this would have an enum, I think, for different layouts. Then based on which layout it is, it like breaks down the space. And then for each, so I have an algorithm in the beginning that for each, depending what kind of initial layout it is, for each node that creates a subdivision that adds to the root of the tree. it changes the state of each node depending on what kind of subdivision it is. So depending on the way that you call setup here, for example, like you would have flag variables, or it would be based on enum. So let's say horizontal, it passes horizontal as true, and depending what kind of variables it passes here to the setup function on this one, you would initialize the nodes on this class here, and then this class here would add to the tree. You would add the nodes as direct childs of the root. But I think that the problem is like, what do you expose to the editor? Because I think I would have to. But maybe not, because if you create the if you create the containers and then you add them directly to the roots of to this node here, so this node would always be exposed to the editor because it's the main node that all the other ones are gonna be added to. But if you always use the same node and then you append, then it becomes hard to know in the editor what is the line between the main structure of the tree that created the division of this space. Because, for example, this node could have like one VBox container, initialize one VBox container, and initializes one HBox because of the way that the first node initializes it. So on the actual scene tree, it wouldn't be one node, obviously it would be two nodes, because it would add directly these two nodes here as children. But let's say this one only adds one VBox. Then like when you're looking from the editor perspective, it becomes very hard to know what was the original structure of the tree that created the subdivisions. But I guess, but maybe if I just make so if I don't expose the VBox or HBox, and I just expose the class. So like I create this class that is gonna like contain the space subdivision, and then I change the structure based on the class, because then the member variables of the properties of the class would allow me to change the state of the container depending which container it is. I think that might be the best option, I think. Because then instead of exposing these classes on the editor, I would just create the main tree, and then the state of the but no, I would add them as a child, but I would add them as a part of the other class. So I wouldn't use the external. So they wouldn't be exposed on the editor, the VBox and HBox, or whatever container I use inside of the main node. They would be created through C++ code by the logic of the class, and then all the nodes would be the same for the main subdivision. And what would change between them is the data. And then through the properties of the class, I would allow. So the question is, but maybe it is not necessary to, because I think that they automatically, like if you add things as children of the other one, like they design this in this way where it kind of forces the whatever is a child to follow the structure. So I think that there aren't many situations where you need to access the containers from the editor to change the values here. But obviously I can create a generic function, I think, that's. So let me write this down. I think that's probably the best way to go about doing this, or trying to do this, but it's gonna be very hard. So the first step is create. I guess I can just add a bunch of functions. So so I'm gonna do this. I'm gonna think about this later. But one solution would be just add. I bet hmm, the functions will have to be based on properties because you have to cache them. I think. Yo, thank you very much, man. Nice. Keep going, man. So want to, if I need to change the state of containers, I can create functions. The main downside of this approach that I'm talking about is that I want to be able to have access to the structure of the subspaces. So it seems kind of redundant to create like a bunch of functions as interfaces. So I would have a bunch of functions that essentially are just proxies that allow me to change the functionality. I guess like it doesn't matter that much because this would be the whole point of the thing. So like you make up the subspace structure based on the purpose of the class would be to have a generic subspace structure where like the functions would be unique because I can, based on whatever I create, I can see if I need to change something inside of that subspace. And if I do, then I can create unique logic depending on which containers you created to create the subtree node. You would have different functionality to change the space. So I don't see a big problem with with not being able to have direct access to the containers. So I think that it would be fine. So probably this approach is the best. So figure out. So this is where it gets complicated, I think, because of the composition thing. So I think it's most likely the case that on the subspaces I'm gonna have to expose nodes. Obviously, I have to make a guess, obviously, because I think that it's gonna be very hard to find uh, s- examples that are similar to what I'm doing. So, but I think that just based on common sense, I think most situations you probably on the dock you would want to have access to different nodes that are parts of that dock. But I think it doesn't matter because the subdivision is going to be based on the generic node. So it's going to be very easy to see like the structure of the tree that created the subspaces because each node is going to be exposed here, the node that creates the subspace. Then the children that of the subspace that I'm going to be able to see from the editor is going to be just they will have to be added as childs. The problem is that so the question is will the be possible to add but if it isn't possible to add them as children from the nodes that get created. So like I'm thinking about this case here. So let's say I create this node here, and this node is the one that is going to be exposed on the editor. And then this node, based on its state, is going to create different nodes that are they are the nodes that actually create the structure of the tree. But these nodes are not going to be exposed on the editor because I'm not going to add them as children. They're going to be parts of the state of this node here. So the ones that you see on the editor, which are the nodes here, are going to be this node here. And then inside of this one, there's going to be, it's going to depend on the state of the node. The other nodes that are added to the actual scene. So the question that I have is, because I'm going to use this node as the entry point to create the dock state, which is going to be based on the other nodes. So like on the editor, for example, each dock is they populate the docks based on the main classes that they have there, which are the import. It's basically these classes here. So I would have basically the same thing, but I would put these ones based on the entry point of the main tree here, which would be like this. So it would be very similar to the logic that they have there. So based on the enum that is determined based on the initial layout that I create, which is this node here that creates the space subdivision, I would have a function on this one that allows me to pass in the same way that I have there an enum that determines the position of the doc that I want to update with a class. And then the question I have is whether or not, like, let's say I'm putting scene tree doc, if I would be able to add them as parts of this node here, because this node wouldn't be exposed to the editor. But I think what I can do is just make the logic on this one. But the question is, like, how do you... So I guess inside of the, like, what's gonna determine this is the logic of the subtree node class. The logic of this class. Because I would put them as children of this, but then how do I determine what is gonna be the structure of the class? So I think that the first step that I have to do is to check if this is possible. So I'm only gonna be able to see this after I create this class here. So the problem is how do you determine the logic? Unless I limit each node to only be, but then it defeats the point of having like this. But maybe this is the way then. So I don't create the other one, I just create the subdivision. So I use these classes to create the division of the space. Hmm. The problem is that then there isn't a way to separate. But I guess I can just use the same node and just change like just do one at a time and yeah, select one box at a time. But then it would be harder to know how it works from here. So maybe the way is to just like just use the containers and don't use the generic class and then just create the whole structure. So I would create just a class that manages the containers, and then the other nodes would be inserted based on the logic of that class. So it would be as if the class is always the root, and then from that class you put the other classes based on the structure. But the problem is that it seems very complicated based on the way that I have here. So the question is how to simplify this. Yo, thanks for the follow. Thinking a lot about this because I know that there is a way to simplify this because the question is I for like creating the whole layout. I think that it's gonna be complex in a way, but there should be a way to simplify the beginning of the layout. So you always like start with something simple, and then the complexity of each part of the thing depends on the classes that. So like the key is to limit the scope. I think like you should figure out a way to create a distinction between the first layouts and uh, the complexity inside of each layout. I think that's the thing. Because the complexity inside of each layout, like I think it's gonna be most likely that most situations you're gonna want to create several different classes inside of the sub layout or like the subspace. So because of the explosion to the editor, like you need to expose the classes on the editor. So the subspace has to. So I guess the question is whether or not can you always simplify. So maybe this is the subtask, is to figure out how to create a class that creates the subdivision of this space in a generic way. So like you have a node that can structure a space. Because the main problem that I was thinking about there is that if I make based on If I have all these types of containers, then how do I decide where I put the node that I want to add to the tree? That's the problem. Because here is very obvious because they're separated. But if you couple them together and then you determine, so I know there is something fundamental here. So I guess I have to study I'm gonna study these classes here, the HBox container. Like I have to understand more how they work. Because I think that there is a generic way to use the classes to. So I don't want to think because it's very annoying as well to think about the classes. So it's more about the subdivision of the space. The structure of the space is reflected on the classes. So I shouldn't have to think about the structure of the space after I create the initial layout, I think. And if I wanted to do that, then should be able to do it from like composition outside of the main layout. So let's say the main layout only goes through. I could have like only this tree, let's say, for example. So the main layout would be like this is the main box, then you have this one, then you have this one. And then so these all of these would be created by a class that creates the state. And then from outside of the class, you can get as complex as you want, depending on the purpose of that space. But I want the initial space to be able to be determined based on a class because then it allows me to have like the initial structure of the page, let's say, which like because in the beginning what I was thinking about is just like this because probably in the case that I want there, I'm not gonna have I'm only gonna have the file system let's say for example, and I'm not gonna have the inspector or this side here. But obviously, if I find a way to create like the separation based on this class, then it allows me to just create the starting point for each one based on the initial structure. And then what creates the complexity is the classes that occupy that initial space. But then on those classes you need to create. So you would be like kind of the subspaces are the subtrees. But then the question is what node you use as the entry points of those subtrees. If the node that I use there on the main tree is not going to be directly added to it is going to be added, and maybe so I have to do that first. So I'm going to study more the classes. I have to study the HBox, the VBox, and the other ones. But that's probably what I'm going to do. So the first thing is to design the first class there. Which I think that like doing the code's not hard. It's just it's thinking about the design that is the difficult part. So I guess I like the best initial point is to think about this first. So do I create a class or a folder for this? So I'm gonna think about the name of this class. So initial step, create the class. So I'm gonna remove this stuff. I guess the other approach would be to create different types of subdivisions. I guess like this is the thing, it is a fractal problem because like the so I think that obviously it's gonna be recursion, but I'm not really sure about the structure because the reflection of the main class, which is creates the first subdivision, is gonna influence the is gonna be the same like nature of the state of the subclass. Like so the question is, what are the combinations, possible combinations of spaces? I think that's it's kind of hard to put into words, but it seems that after I thought about, I do think that the way that they design things, it is similar to the way that it works on the end, but it is different. And I think the difference is the way that they subdivide the space. Because like on the front end, you have like Flexbox, and I think you can do the same thing with the containers on Godot. So it's kind of like the same logic. But what changes is the structure of the tree that creates the thing. I guess like this is why it's hard to. But if you create a generic node to encapsulate the structure of the space, the problem is that you have like the nature of one of the spaces is going to depend on the state of the parent. So if you have a, but I guess like this would be the decision of the layout, which would be the first state. But let's say if you have a V box, if you have an H box that is a child of a V box, I believe you have a different layout than if you have the other way around, where you have a V box that is a child of the H box. So it's difficult to think about like how do you make sense of the. I guess the challenge is the how to think about the algorithm that creates the division of the space that creates the layouts. I think this is the key to think about this, but it's very hard to think about it because those things are obviously connected. The division of the space and the algorithm to so like the structure of the node that holds the subspaces and the algorithm that creates the logic to determine the structure. I guess this is the thing that I'm contemplating because this is where the gradient is, I think. Because one way to think about it is that you have like you just so one extreme would be you just create a tree from all different types of containers, in which case the algorithm would have to select the container based on the subdivision of the space. So like it's all gonna be encoded based on the enum. So like the enum is the entry point. So let's say you have an enum in the beginning that's I can put different names that I want, obviously, to determine. So let's say one enum would be ID, which would be a layout that is the same of VS Code here, where I have or similar to VS Code, where I have one dock on the right and one dock in the middle and one dock in the bottom. Then based on this, you can the logic of the algorithm to create the first tree data structure that you would divide the initial space into the three docks would determine what kind of node from Godot to use to create the subspaces. So the problem with this is that the tree structure that the algorithm creates wouldn't reflect the amount of subdivisions, if that makes sense. So like the amount of subdivisions are true because obviously you have three spaces. So like the first one creates let's say you start horizontally, so the first one would create this dock and this dock, the first division. And the other one, you would divide this space, let's say, into two, so it creates this dock and this dock. So this would be the tree structure. But if you only use Godot classes, then it might be the case that for each division you make, you need more trees, you need more nodes on the tree to represent that division accurately. And this is going to be directly related to the type of layout you want to create. Because the type of the dock is determined by the type of the node you put there. So this is the challenge, I think. And I think the other way would be the way that I was talking about, where each node is each node of the division contains all the containers. And then you select the structure of that subspace based on what type of layout it is. So the question is, what is the middle way? I guess what makes this difficult is the thing that I was talking about, is that in this example, I think that if you make this node as a child of the other one, the subspace, then it's going to change which kind of node you would select to create the correct structure. That's the problem. So like if this subdivision created a VBox here, for example, then you would change what kind of node you put here to create this other subspace. So I guess this is the question, true answer. So can you always put an H box to create the second division here? Yeah, so the question is how do you select which node? How do you select which container to use based on the division of the space? I think that the subspaces would be created based on an integer. Maybe this is too complicated. Or maybe this is not the best approach. Like it would be easier if I just had the structure based on the name first, because it's easier to think about the names instead of creating this. But then I think that it would be a different approach. Because it's obviously easier to think about, like, when you think about a scene, it's easier to use ID, for example, and then you already have in your mind how the scene is gonna be, then to create the. But I guess it would be the same thing. It's just changing when you create. But if I create it outside, then it would be just creating the structure based on the V box, H box, to represent the whatever I want there. I guess this is the way that I was thinking about before. That's why I was thinking about creating different functions. Maybe this approach is easier. So like I would have create ID layouts, and then I would just create the tree data structure that has all the nodes of the containers that creates the layout in the beginning. And then from that point, I would navigate that tree, and I would add the other stuff. So maybe this way is better than the other way. I'm not really sure anymore. And the problem is that both. So what I have to do is just study more the H box and V box, because I need to clarify exactly how they. I need to clarify how they determine like how to structure the space based on the children. I'm not really sure if it's gonna be. It's already grading here. Also, yeah. So they're both variations of box container. I guess I can try both approaches and see what happens. That's probably the best thing to do. Because it is very similar, it's just a different way to accomplish the same thing. But the approach with the functions, it seems easier to think about, because if you think about like the integers, it's kind of hard to. But I guess you would encode anyway there. I guess in both ways, it's kind of hard to think about like how to find the node that I'm gonna add. Uh, so after the initial layout, how do I find the entry points to add the main ones? But I guess it's just gonna depend on the complexity that I want at the beginning. Because here is not, it wouldn't be an accurate representation. It's just the class or the function would be just a simplification of all this stuff that shows up here. Because it would create less complexity, because it would divide the space less times. So I can make it based on the same enum that they use there. So left, right, stuff like that. I think even here is already too complicated to put. These names here are very confusing. I think I'm gonna create as a task the class because you have to remember either way. So the way that I was thinking about is like using integers through because the integers would represent the division of the space. So after you create the structure of the layout, you use the integers to determine what entry points would the other nodes uh, that would create the complexity inside of the dock would be instead of using the enums, and then you would use the enums to create the layout, which creates the subtree data structure or the subspace data structure in the beginning. So you create the subspace, then you navigate the subspace based on the layouts and the entry points. Then from the entry points, you create other functions that create the docks. So I guess I can put functions on the main class as well, and then I make based on the integer. Hmm. I think the class makes sense actually. So maybe the class is the best to do. So the only thing that I have to clarify is the how the classes work here. So how do they divide the space? But I think I probably can assume that the H box is just going to divide horizontally and the V box divides vertically. And then when they are added as children of the other, I think it's worth to do the experiment. So let me think about. Hmm. So I guess I can create another class just to differentiate what creates the initial layout and the stuff that creates the other stuff. But then each node would be the same. So it would just select what kind of container it is based on the layout, and then I figure out later. So like it would be essentially the same thing, but the difference is I would be able to visually see what nodes were created by the initial layouts of the initial class and what if there are more if there are H boxes or other kinds of boxes, you would allow me to see that they were created by the by the nodes that were inserted on the subspace from the main layout. So I designed another class that is only gonna take one node. So it can only be one type of container. But inside of the class, it has all types of containers. So it selects which kind of container it adds to the tree based on the state, which comes from the root. And then The complexity comes from the algorithm that I have to create initial structures based on what I want. And then these kind of classes I would put from outside. So what would show up here would be just in the first step would be just the nodes from the main layouts tree. So I can change. I was thinking about doing this. So create another pattern which would be layouts for the initial nodes. So maybe the name should be layout node. So this class is gonna have. So either I'm gonna. I think. So one of the questions is like, does it make sense to explicitly put there as member variables each container, and then just initialize all of them as null pointers? I think it probably doesn't. Like if I can avoid it, it's probably better to avoid because then it prevents from just using extra memory, I think. But this class would have the logic that determines what's. So it would probably be a control node, I think. Yeah, so that's control. I guess for the class that inherits, you need to specify to import. So, or to include singular control. And if I need, I put the GD class thing there. I have to register. So now the question is how to structure this. So the thing is, like the parent of the. So I think that the roots of the node would be layout roots, and I'm probably gonna create here as well. So based on the initialization of the layout roots, it has to change the state of this class in such a way that it creates the. Let's say it is based on an enum or something like that. Let's say if horizontal space, then you create the hbox container. And then you add as a child. So I guess the variable would be a container and it would have to be a control node. Because all the containers are gonna inherit from this, and then I do the logic based on this one. So all the functions on this class would be are gonna cast the type to see what kind of container. Either cast the type or see. Yeah, it would depend. So the properties of this class would change this, I think. I'm not really sure if this works though. Or instead of making all containers, I can simplify and just do the ones that I think are gonna be used most often. And then in case I want something else, I do it outside. That's also another option. And I would add this child. So I think I'm gonna stop here. What I'm gonna do next, I have to think more about this. So the main question that I have is whether or not this is gonna work if I put like this generic variable here, or if I can also, the other option would be to limit the amount of containers the class has, and then if I want to add extra stuff, I just do it outside of the layouts. I'm gonna use these as entry points. So it's very similar to the way that they did there, where they created this function to add the doc classes based on the enum. So the only difference would be that in my class I would have the layouts as the enum, and then depending on the layouts and the other enum or an integer, or depending, yeah, the layout would have an integer, I think, that would represent the spaces. I think it has to be an integer because it has to be generic. So it would have to work for multiple different layouts. So depending on the integer that it would represent each subspace that the main class creates and the main layout that the class has, that the class was initialized with, I would be able to add the docs in the same way that they are doing here. So the question is whether or not, so I guess I'm gonna spend more time to see if I can figure out because here it's kind of confusing. I don't know. It probably depends on other stuff that happens after this that I don't understand very well. Because I should understand how is it possible that they create. They like I can't really figure out how how is this gonna be used to actually create a separation there after that. That's the problem. Would be here, but the other challenging thing is that I know that they use. I think that they use the context doc pop-up context or whatever the name of the class is to context pop-up. Maybe it's this one. Maybe the is this one to cache the docs because I think you can also change the. You can put the docs on different positions. I think based on stuff that I've seen from other people. So I do think that it's possible to change the places of the docs here. So they also have a way to cache this as well. And they save on the editor config files. The problem is that I don't think that this is related to the stuff that I'm trying to clarify. It's more related to the functionality of the docs. But I'm not really sure like if this is related to the layout of where the docs gonna be placed. That's the problem. It could be inside of the classes. This is the issue. So like intuitively, I think that it can be simplified. It doesn't seem that it seems that it's more complex than it has to be. That's what I feel like. But obviously I don't know because I don't understand all the classes very well, so I could be wrong. So it's probably based on these default layouts. I remember that this is probably it comes from the config file that they cache. So the editor settings caches this file. So based on this file, it probably so it maybe I think it's on that function, but I remember looking into it and I'm not really sure. It has to be this function here. So I'm not really sure. It- Like it seems that it doesn't have anything here. It's just updating the. Also, it probably maybe it happens maybe through the notification function. I can see where it's gonna create the layout based on the other class. So this function here probably. So this is the function. So this function here is probably the one that is definitely the one that's gonna get the config file and then it's gonna separate the classes. So the control node is the one that it puts there on the based on the when it was at registering. So for example, this would be the Sync3Doc class here, and then it's gonna map to the other structure that they create there to determine the states of the doc which they're accessing there. So maybe this one, but this one is just for the file system. So it allows layout. So probably these move docs here. In doc at parents. Yeah, so I think that the difference is that this class here that they create this structure before. So they manually create this structure, which is different than what I'm thinking about. And then this class is just gonna is gonna be the one that selects where to put each doc based on the structure that they created before. So they create this structure manually there through the nodes, which is the code that I copied there. So this code here is the one that they use to create the structure in the beginning. Guys, this is the difference. So the doc manager class there, it doesn't, it is not the one that is used to create the structure. It just use that one to select where from the pre-existing structure the docs are gonna be. So it's different than what I'm trying to do. What I'm trying to do is create a class that is gonna create the initial structure, and then from that class I select. So I guess it's different. But I'm gonna stop streaming here, and what I'm gonna do next is just think about this class here. So I'm probably gonna create another class called layout root. Then the layout root is going to be the one that is going to have an enum inside of it. Then based on the enum, it's going to have different starting structures for a scene. Then the enum is going to determine the logic of the algorithm that's going to create a tree that is going to subdivide the space. And based on the subdivisions of the space, it's going to create layout nodes. So the layout nodes are going to be the structure of the tree. And the state of the layout node is going to be the thing that determines how we select the Godot classes to create the structure of that space. So there's a bunch of things to clarify, but I think one example would be just to, like, in the beginning, you create a subdivision based on which layout it is, and then you pass a variable, like I explained there, that would determine that the subdivision is horizontal, for example, because you want to create these spaces here. So let's say in the beginning of the layout, let's say you have the IDE layout, and then based on the algorithm of the root layout, the first subdivision is going to be between this space here and this space here. So you would instantiate two different layout nodes, and then you would pass the horizontal space flag for both of them. Then based on this, they would both create the HBox container and add to the parent, which is the root layout. Then the root layout would continue to add, to subdivide the space. Or I would have to think about a way to keep dividing recursively based on what layout it is. Then after this initial setup, the editor node will have exposed the layout nodes, and from the layout nodes, I would have the entry points to add the remaining parts. So the more complex stuff would be made from the beginning. So the first subdivision would just create the main sections of the scene, and from that point, you would have the entry points based on what kind of layout it is, and an integer that represents which part of the subspace you are. Then each subspace, I would add other nodes that would manage the complexity of whatever is going to happen on that subspace. So I could have only one node that is added as a whole, which would occupy the whole dock. Or I can have a composition of several nodes inside of that space that creates more complex spaces inside. But then I separate them, I make the distinction so that it doesn't get too complicated, because then obviously it's impossible, I think, to create a structure that because at some points you need to separate what class is responsible for what, because it depends on the data of the application. So there is no way to integrate a generic way to subdivide the space even further. If you can have one situation where you're going to have a text inside of that subspace, another situation where you're going to have a 3D node that has a simulation, for example. So because you can't predict the data and there's too much variance of the data, there's a limit to how far you can go with the subspace division, which is why I think it makes sense to separate them both. So from that point on the initial state, then if you want to have a subspace that has more complexity, which means like you have different tabs on it, you would separate that logic either from creating other functions that compose the state from different nodes, or by creating another class that contains the whole complexity. So that's what I'm going to do next. But I'm going to stop here because I'm tired already. So I'm going to think more about this, on how to achieve this. Yeah, I think it doesn't make... I should probably start from the beginning. So probably next time, I'm just going to start. Because here is not going to be... I think I'm going to spend too much time focusing on stuff that doesn't matter for my case there. Yeah, like the most amounts of time is gonna be like, also it's probably better to think about like how to allow to change the docs in the same way that they do here, by changing the state of the root layout class. So most of the time it's gonna be thinking about how to structure, and I'm probably gonna watch videos as well to clarify, watch videos and spend more time studying the classes to clarify how exactly they divide things here. So the box container, and I'm gonna write down the main ones that are used most often. Then based on that, I can, because there's the other question that I'm thinking about, which said before, which is like whether or not you put like one generic container here, which would be a control node, or I put like three different ones that, and then I limit the amount of containers each layout node can have. Or I can try to do both, where I put like standard ones and then I put the generic one. Maybe that's the best way. So I would put like VBox and HBox as the main ones, and then a generic one in case I need to specify. Yeah, so I think that it makes more sense to think about it from the beginning and use color rectangles to be able to visualize the difference on the nodes. So like I have to clarify how the classes work and the relationship between them on the hierarchy to see, because I'm gonna have to think about that when creating the algorithm to create the subdivision of this space. Because in the way that I did the Barn subparameter for the simulation, I'm always subdividing based on the same. I guess I subdivide based on the minimum or the maximum size or something like that. And I remember that this is the hardest part, I think, to think about. It's like, how do you decide if you're gonna divide the space horizontally or vertically? And I have to see if the way that I'm thinking about the classes from Godot is the correct way to think about the division of the space. But I guess I can try experiments as well. So probably, yeah, next time I'm probably gonna do experiments with this. So create different classes, create this class, create the tree, create the algorithm to create the subdivision. Probably create a color rect here instead. I think color rectangle is the node that allows you to see like to create a box to see what the layout would look like. So probably that's what I'm gonna do in the beginning. So I can create the nodes. I can create a bunch of algorithms to test the different separations of spaces based on the main algorithm and see what that looks like. Then from that point, I think about the rest. So see you next time.